So what we've got here proving angles congruent, we're using geometry to do proofs. An example of this, quilter wants to duplicate but knows the measure of only two angles, the 90-degree angle and the 60. Go ahead, find angle 1, 2, 3, and 4 with your group. Go. What's the measure of angle 1?
30.
Good, 60 and 30. And so what's the measure of angle 2? 90. What's the measure of 3? 60. It's vertical with the 60. What about 4? Also 30. Very nice. So we're using a lot of the angle relationships we know. We're also going to be using properties of equality, properties of congruence, postulates, and definitions. So we have the addition property of equality. There's also an addition property of congruence, multiplication property, division, subtraction. We also know the reflexive, transitive, and symmetric. I'm just highlighting different properties that we already know. Whoops. We know some definitions. This is really important. We've already encountered a definition. We use definition of supplementary to state that two angles add up to be 180, by definition of supplementary. We also have by definition of midpoint. So if we know we have a midpoint in a segment, by definition of midpoint, we can set these two segments equal to each other. Same thing with vertical angles and supplementary angles and complementary angles. These all use definitions. This is really important. You're going to be using these throughout the year. Definition of bisector. We have yet to kind of include this in here, but if I'm stating that a ray is a bisector, by definition, I can say that the two angles are congruent. So we use definitions a lot. So we're going to look at a couple of postulates: angle addition postulate, linear pair postulate, which we've already encountered, and segment addition postulate. All of these guys important throughout the entire year. Linear pair postulate. Two angles form a line. Therefore, they are supplementary. We've used that. We're going to keep using that. Let's look at our first proof down here. We've got given the diagram, prove that x is 41. We are only given the diagram, which means line 1 cannot be given. Okay, did everyone hear that? You're only given the diagram, so line 1 cannot be reasoning given. It needs to be something else. So I would like you to try this with your group. Let's go over this now. So number 1, what allows us to say that angle ABC and CBD are supplementary? Nice, linear pair. Number 2, what allows me to say that now those two angles add up to be 180? So we're using the idea that they were stated as supplementary. Now we're saying by definition of supplementary. 3, what allows me to going from saying that ABC, which ABC is this angle here, and I'm writing that as 3x minus 25, and the other one, CBD, I'm replacing with 2x. What is that? I'm taking out the angle name, replacing it with what it's equal to. Very nice, substitution. 4, what did I do to 3 to get to 4? So I see you doing the 3x plus 2x, right? So combine like terms or substitution, because you're substituting with an equivalent value. Subtraction. Subtraction property of equality would be happening to both sides, and that's not happening here. So I like combine like terms. What are we doing to line 4 to get to line 5? We're adding 25 to both sides, so that is addition property of equality. What are we doing to line 5 to get to line 6? Dividing both sides by 5, so this is the division property of equality. Nice. Questions on that? Did anyone get all of them? Ooh, well, that's very impressive. Very impressive. Okay, let's go over here. We are given, so we've got a diagram here. We're given that 6 is congruent to 2. So this is number 1. Go to the diagram and mark those as congruent because we can build on that. That's the thing that's given. That's what we want to build on. We want to prove 5 congruent to 3. Our steps are listed. You come up with the reasons. Work with your group. Go. All right, let's see how you did. Line 1. What allows me to say 6 congruent to 2? Yeah, it's given. It's right here. So this one we can put given. Line 2. What allows me to say 2 is congruent to 5? Now notice where you're looking. You're looking at the diagram and you're noticing the relationship between 2 and 5. 2 and 5 are vertical. So this is because vertical angles are congruent. Very nice. 6 congruent to 3. What allows me to say that? 6 and 3 in the diagram are vertical. So this is also vertical angles congruent. Now notice, we've been looking at the diagram to notice a relationship. That's one way to get the reasons. There's another way to get the reasons. Look at line 4. What's the connection between 6 and 5? If we looked at the diagram, the best we can say is they're adjacent. And as you know, adjacent angles tells us nothing. So instead, we're going to look at previous statements. And there should be a connection that we can make. So, do you see anything?
Transitive because 5 to 2 supplementary.
I think a lot of you, we got 6 congruent to 2. 2 is congruent to 5. So 6 is congruent to 5. Does everyone see that? So that is the transitive property. What allows me to say 3 congruent to 5? Also transitive because there's another connection, 6 to 3. So this is also transitive property. Okay, how'd you do on this one? Good? Brilliant. Let's go next page. Go ahead, work on this one with your group, and then we'll go over it. Vertical angles congruent. So you did 3x plus 8 equal to 5x minus 20. Solve this, and what did you get for x?
X equals 14.
So that worked for you. Perfect.
I did 3x plus 8 plus 5x plus 4y equals 180 since they're supplementary angles.
Now we can get the y value. These guys are a linear pair. Therefore, they add up to be 180 because they're supplementary. And we can do what with the x's? You got it. Substitute with 14.
Y equals 15.
Yep. And then y equals 15. If you started with the linear pair, what did you notice? Like if I did not solve for x, I would have 2 variables, 1 equation, and I can't solve that. That's a system of equations. So then you go back to the diagram, literally, and you figure out what other connection can I make so that I can set up an equation that I can then solve. Okay, excellent job. Equality and congruence. Equality is equals. Measures are equal. So the measure of angle 1 equals the measure of angle 2. Angle 1 is congruent to angle 2. I mentioned this a while ago. I'm bringing it back. Because we can go from one to the other by definition of congruence. Measure of angle 4 equals the measure of angle 5. Angle 4 is congruent to angle 5. The length of AB is equal to the length of CD. Segment AB is congruent to segment CD. So pieces of a diagram are congruent, but their measures are equal. So that's a connection between the two. Go ahead, figure out which statement is wrong, and then we'll talk about it. Go. You're right. So the fourth one's incorrect. What should occur here? We should have the little m's indicating that the measures add up to be 180. Nicely done. A theorem is a conjecture or statement that you prove to be true. So that would be a proof, a statement, reasonings, so that we can prove it to be true. You can use given informations, definitions, properties, postulates, previously proven theorems as reasons and proofs. Hence the handbook to use as all of those previous things that we can use for any proof we encounter. Vertical angles theorem. If two angles are vertical, then they are congruent. We were given angles vertical, and we proved that they were congruent. And so with this, we use the linear pair postulate. We actually did this as our warm-up. Here it is as statements, and you can see where our reasons go. So we've got given, linear pair, definition of supplementary, transitive property, subtraction property, and definition of congruence. So that last one can be definition of congruence, or if you ever forget what that is, you can always say angles with the same measure are congruent. That's true. And that could be your reason, for sure. Yes? Ooh, good question. For number 4, so yes, transitive would be the better idea here. This one, sorry, it's too easy. Go ahead and solve. What do you get? Yeah, because you get 3x equals 2x plus 40. Subtract 2x, and you get x is 40. Too easy. Let's go over here. Proof using vertical angles theorem. This one is going to be for extra practice. So when you want to practice something, there you go. And then we've got some other theorems I want to talk about. Let's go down here and look at these. So the first theorem, congruent supplements theorem. If two angles are supplementary to the same angle, then the two angles are congruent. Here we have 1 congruent to 2. And we just saw that. Congruent complements theorem. If two angles are complements of the same angle, then the two angles are congruent. So we get that angle 1 is congruent to angle 3 here, because they're both complementary to the same angle. All right angles are congruent. So we get that angle 1 is congruent to angle 2 because they are both right angles. And then down here we have if two angles are congruent and supplementary, then each is a right angle. So we get that the measure of angle 1 is equal to the measure of angle 2 is equal to 90 degrees. They're both equal to 90. Those are our theorems. Now, a theorem is different than a postulate. Postulates are foundational. A theorem could be proved to be true. So we could do statements and reasons, and the if part is the given, the then part is what we want to prove, and we can do our reasons in between. Something to keep in mind. So these are our new theorems listed out, and I believe that's it for your notes. Thursday.